All right, this is the third video for your formative review. This is going to cover indicator 7.2, which is representations and things like that. So this is going to be question 6, question 7, 8, and 9. We'll see if I maybe split it up into a couple of videos, but for right now, let's go ahead and get started. So question number 6, part A and part B ask about finding the domain and zeros. So let's start with domain. All right, so D for domain and Z for zeros. So to find my domain, I have a fraction here, right? And for the domain, I am going to specifically set the denominator equal to 0 to find out what values make the denominator equal to 0. Because any of those values that make the denominator equal to 0 have to be thrown out of the domain. So we're going to go negative infinity, negative 6, and then negative 6 to infinity. The parentheses at the negative 6 mean that we get right up to negative 6 from either side, either positive or negative, but you can't use negative 6 itself. All right, so that's the domain. Zeros, I am going to set the entire function equal to 0. So 3x minus 2, oops, this is skipping a little bit. So 3x minus 2 over x plus 6 equals 0. I'm going to cross multiply, all right? Now, you might be wondering about the cross this direction. 3x minus 2, this would be times 1, all right? So that's just going to be 3x, nice little pen skipping here, minus 2. And then the other cross, well, 0 times anything is still 0. So let's go ahead and finish solving this. I'm going to add a 2 to both sides. So 3x equals 2, divide both sides by 3, and my 0 is 2/3. So those are the domain and zeros for question number 6, part A. All right, so question number 6, part B, asks again, same thing. I want to find domain and zeros. So D for domain, and I'll change colors, Z for zeros. So for the domain, I have a radical this time. Right, so this lovely little root, and what I'm going to do, first of all, is move those over, and I'll use this as my working side. Okay, so to find the domain, I am going to take the expression under the root and make sure it is greater than or equal to 0. All right, because that will force it to be positive, because I can take the square root or the root of a positive number, or I can take the root of a 0. I cannot, with real numbers, take the root of a negative. So solving this, right, so minus 3 on both sides, and that tells me t has to be greater than or equal to negative 3. So on the number line, right, here's negative 3, greater than or equal to is only in the direction going to the right. So my domain here is going to start at negative 3 and go to positive infinity. Infinity gets a parentheses, and negative 3 gets a bracket because of the equal to component. All right, then for zeros, let me do a quick squish and shift. There we go. For the zeros, I'm going to take the whole expression here, including the minus 4, and set that equal to 0. So this is going to be the square root of t plus 3, write a minus sign, minus 4 equals 0. All right, solving this, we're going to add 4 to both sides. So square root of t plus 3 equals 4. I'm going to square both sides to get rid of the root. So t plus 3 is equal to 16. 4 squared 16. Subtract 3, and I'm getting t is equal to 13. Now I should, for the 0, and I will do a quick check. All right, because I want to make sure if I put 13 into this expression that I get that value of 0, and then it works out. So if I check this, right, so 13 plus 3 minus 4, that should equal 0. 13 plus 3 is 16. That was a huge root. Let me kind of squish that down just a little bit. 16, square root of 16 is 4. 4 minus 4 is absolutely 0. So that does check. All right, so what that means is these two, we've got the domain, we've got the 0. All right, so that's question number, where'd it go? Question number 6. All right, question number 7, I want to find an inverse. All right, well, to find an inverse, we're going to first swap x and y. So remember, that's your y value. So x is equal to 4y plus 3 over y minus 5. I'm moving it over to the left just so I have some space to write and work. And I'm going to put this over 1 because I'm going to cross multiply. And I want to be really careful with my crosses here. So crossing from denominator to numerator this way, I get 1 times 4y plus 3. And crossing from numerator to denominator this way, I get a pen. So x times y minus 5. I'm going to distribute on this right side, so xy minus 5x. And now this is where it gets weird because I'm trying to solve for y now. I want to get all of the y's together. So I'm going to subtract xy from both sides. At the same time, I'm going to subtract a 3 from both sides. All right, so let's see. 4y minus xy. 3 minus 3 is gone. Xy minus xy is gone. Equals negative 5x minus 3. On the left side, I'm going to go ahead and factor out a y. So y times 4 minus x equals negative 5x minus 3. We're almost there. All right, so close. Divide both sides by 4 minus x. All right, and we're getting y is equal to, let's see, that's going to cancel out. So negative 5x minus 3 all over 4 minus x. The last thing to do would be to put it in the inverse notation, so f inverse of x. So negative 5x minus 3 all over 4 minus x. That is the inverse. Whew, all right, we did it. All right, that's question number 7. Now, the nice part about question number 8 is it's the same. I'm trying to show it so you can see it. This expression, this function right here is the same as the function we just worked with. So when we talk about finding the range, we'll be able to use that inverse we just worked with. All right, so I'll get back to range in a minute, but let's talk domain. We actually had a problem like this earlier. So remember, for domain, we're going to set the denominator, but purposely set it equal to 0 to find my problem numbers, which in this case, the problem number is 5. If I put 5 in here, 5 minus 5 is 0. And unfortunately, folks, last time I checked, we are not allowed to divide by 0. All right. So I have a domain. It's everything except for 5, which is awesome. Let's talk range. Now, the range of the function, right, this is my function, is the domain of the inverse. So I'm going to go to the inverse that I have here, which is sitting right over here. And I'm going to do the same thing that I just did for this last problem to find domain. I'm going to find, right, what makes the denominator equal to 0. Well, what makes this denominator equal to 0, which would be the domain of this inverse function, is the range of this function. All right, so all the words. So I'm going to take 4 minus x equals to 0. I'm going to go ahead and add x to both sides. So 4 is equal to x. So everything works. Hold on, let's not make a minus sign there. Let's make the minus sign there, except for the number 4. So 4 to infinity. All right, so we found the domain. We have found the range. Ta-da. All right, and the last question on the, I think it's the last question on the review. No, yep, last question on the review. Question number 9 here is one of the problems that you have to create your own equation for. So let me take a moment to read it, and as I read it, I'm going to kind of mark some things. So let's see. The fare for the airline is $300 per person. If we have 100 passengers or less. The fare is decreased $2. Actually, let me change color back to that green. Decreased by $2 per person for each passenger in excess of 100. Okay, so I don't even care really what the questions are asking right now. What I want to do is take all this information and turn it into an equation for revenue. Now, you can call the equation anything you want. Really, it does not matter. But I'm just going to put this off to the side. I will call it, because I'm super creative like this, R of X for revenue. And what we have going on here is we have money and we have people. Okay? So that is what's going on. And let's see if I can make this work. Okay, so for our money, we had $300 per person. So that's $300 to start with. And for our people, we had 100 passengers or less. So this is what happens if your people is 100, if your people is 80, but we'll go with 100. Okay. So now we need to change the situation. So we've got the fare. That's going to be the money is decreased by $2. So -2. But here's the thing. I don't know if I do this once. I don't know if I do this twice, 8 times, whatever it is. It's going to be -2x. Okay. And then for people, this is for each passenger in excess of 100. So, right, plus 1x. So if this is 1 passenger, awesome, you get -$2 on your cost. If this is 10 passengers over the 100, then I would take 2 times 10, subtract that from my 300. So now I've got my money and people. And again, I'm not even looking at the questions yet for the A, B, and C part. I want to multiply this out. So R of X, oh, I lost the pen there. There we go. Let's do some multiplication. So 300 times 100 is going to be, I think, 30,000. Do I have enough zeros there? 2 from there. Yep, I do. And let's see, 300 times 1x, that's going to be 300x. Minus -2x times 100, so -200x. And then -2x plus 1 or times 1x would be -2x squared. I'm going to rearrange this into standard form. So -2x squared plus 100x plus 30,000. Make sure I get all my zeros there. All right, this is my revenue equation. So this is going to be fabulous to deal with getting my A and B value. It's in standard form. Love that. And then this equation, the top one here that I originally wrote with the first part where it's like, this is my money, this is my people. This is going to be super helpful if I'm looking for one specific answer. Now let's look at what the questions are asking for. All right. So part A asks what price per passenger will leave the maximum income or maximum revenue. What number of passengers will produce the greatest revenue, and then part C, what will be the maximum revenue. Awesome. So all of this is dealing with maximums. So I'm going to go back over here, find my equation, and folks, we are going to find the vertex, specifically the x value of our vertex. So -b over 2a. So, whoops, I'm not sure I'm writing x again. Let's try that again. So let's go -100 over 2 times -2. So -100 over -4, what is that, 25? All right, so what this is telling me is that we need to change our prices. Actually, we need to add an additional 25 people, which will change the price 25 times. Okay, so let's see. What price per passenger will yield the maximum revenue? So money is the part that I'm looking for here. So 300 minus 2x, and x, of course, is 25. So let's see, 300 minus 2, x is 25. And so if you need a calculator, great, go ahead and use it. Clear out what else was in there. So 300 minus 2 times 25, 250. So what price per passenger will yield the maximum revenue? I'll go ahead and throw this off to the side. $250. Okay. What number of passengers will produce the greatest revenue for the company? I'm going to just slide the calculator over a little bit. Oh, I was trying to make it just slide a little bit. It just decided to go off completely. So part B, number of passengers. So if I look at my equation here, the number of people, right, those are my passengers, is 100 plus 1x. All right, so let's see, 100, there's a 1 there, 100 plus 1, and x is, of course, 25. So 100 plus 25, I'm not going to bother throwing that in a calculator. That's going to be 125 passengers. I'll put people since I'm going to run out of space trying to write the word passengers there. All right, and then the last part is what will the maximum revenue be? All right, well, you know that the number of people to maximize the revenue is 125. You know that the price to maximize is 250. So I'm going to simply take the price, 250, times the number of people, and that'll get me my maximum revenue. But in order to do that, I am going to grab back my calculator. All right, so 250 times 125 is, all right, let's see what we got here. 31,250. That is, of course, in money. So let me slide that over, and money it will be. All right, now I don't need the calculator anymore. All right, that's in a box. That's in a box. That's going to be in a box. So we know what their answers are. All right, this one was probably a pretty lengthy video in terms of time-wise, but it is all the bits, parts, and pieces for indicator 7.2. Let me know if you have any questions or concerns, and remember your formative is going to be on Monday. All right, see you in the next one.